Alright, hello everyone. My name is Nemeth Tamas. I'm a front-end engineer at Liligo. Previously I worked at EPAM. I like playing percussion instruments and I like dancing folk dances. And I'm also the happy father of a 2-month-old baby girl. So some words about the host of this meetup. Liligo is a search engine that lets you compare flight options and other transportation options, whether it is bus, train, car sharing or car rental, in one application. This bot you've just seen is from our mobile iOS application, and we're currently rewriting our entire application, web application on a 2018 stack. We're also looking for a senior front-end developer to join us and for test automation engineers. So I'm here today to share our story with you about how my team replaced our previous end-to-end testing tool Protractor with a combination of Jest and Puppeteer. But before starting to compare these tools, let's just take a look at how end-to-end testing or automated testing fits into the big universe of web application testing. You've probably seen this pyramid before. It's from the 2014 Google Test Automation Conference, and it visualizes the proper ratios of the types of tests that you should write for your application. The basis of this pyramid is unit tests. A unit test tests a single unit, function or class of your application in isolation. As a result of that, because you only need to load that single unit and its dependencies or the mocks of these dependencies, these are relatively quick, reliable, and when they fail, they'll tell you exactly where the problem lies. Now, the creators of this pyramid have also attached ideal percentages to the layers of this pyramid. How many percentages do you think unit tests should make up of all your test base in an ideal situation? How many percent?
80.
80? Other guesses?
0.
0. Okay, Google says it's 70%. Now, the way more of these units work together can be tested with integration tests with an ideal 20%, and only the remaining 10% is left for automated tests or end-to-end tests. Now, in the case of a web application, these tests start up a browser and they interact with it. They fill in forms and click buttons, and they simulate complete user flows. Now, because of this, because of having to start up a browser and to load your complete application, these tend to be rather slow, and they also tend to be rather fragile. For multiple reasons. One of them is that these rely on CSS selectors, and markup is always subject to change, and because of all sorts of asynchronous issues, you might want to click on a button that is not there on the page yet. So, in the next step, let's take a look at what tools we have had historically to automate the browser, focusing mostly on the JavaScript ecosystem. So one of the first tools that let you automate the browser was created by a company named ThoughtWorks, and it got its name after a joke, actually. One of the competitors of ThoughtWorks was a company named Mercury. They also created automation software, and it's a medical fact that selenium can cure mercury poisoning, so they named that tool Selenium. The RC, after its name, it was added added later, and it refers to this first version of the software. The way it worked was that you started up a remote control server that acted as a proxy server, and also started up your browser, and on a specific URL, which served a piece of JavaScript that was called Selenium Core, and it could interpret commands sent to it and carry them out in the browser. Now, at this point, we didn't have JavaScript binding for it, but it was available for libraries were available in multiple languages. Now let's jump over some years to the release of PhantomJS. PhantomJS was a headless browser, completely written in JavaScript, and it used the WebKit rendering engine. Now, headless browser is a browser without a graphical user interface, and it is useful in scenarios when you want to execute something in the browser, typically execute an application, but you don't need to see it. For example, crawling, scraping a website, or especially single-page applications, or server-side rendering, or automated testing. Still in the same year, Selenium joined another group that started out at Google and was called WebDriver. They attempted to address the problems Selenium had. The guys met at the conference, and they decided to merge these two projects, and so was Selenium WebDriver born. This version, instead of Selenium Core, operated with browser drivers. They implemented a browser driver for each of the drivers, whether it was a binary or a browser extension. It didn't matter, and you could communicate to these browser drivers over HTTP, over the JSON wire protocol, and they executed the commands you sent to it in the browser. Now, in 2012, that was probably one of the first JavaScript libraries that was able to control the browser directly, and it was a client for Firefox's Marionette.js protocol. You could start up Firefox with the Marionette flag, and that started a server with which you could communicate over the socket and send commands to it. There was also a complete framework built around this client, but the whole project was abandoned in 2016. Now, 2012 saw the release of PhantomJS version that had browser driver integrated to it. So from this point, you could actually run your Selenium tests against PhantomJS, which was particularly useful in a continuous integration environment. Somewhat later, WebDriver guys released the official language binding for JavaScript, and from this point, you could already write your tests in JavaScript, and there were other tools that built around WebDriver.js. One of these is Protractor, created by Google. It builds around WebDriver.js and integrates with Jasmine, Mocha, and also integrates with the Angular or AngularJS framework. With its internals, it it waits until its events fire. Still in the same year, Chrome guys also released a tool that was able to control the browser directly, and was called Chrome Remote Interface. It was not really used for end-to-end testing, but provided a low-level API for sending commands to Chrome over the DevTools protocol, which was back then called the Chrome debugging protocol. And let me just show you some examples of what this is useful for. So this instance of Chrome, I have started up with a special flag. I have applied remove debugging port flag to it. So this means that that I have a server that's listening to WebSocket commands, and with the help of this, I can debug any of my pages open in the browser remotely. This is, for example, my presentation. I can just open it, and on a separate tab, I'm debugging another tab. All right, so we also have a JSON endpoint that's listing the same pages, and this is also listing the WebSocket URLs over which you can connect to these specific pages. This one is my presentation, and I'm just going to open up a new page and connect to it over the DevTools protocol. I'm creating a new WebSocket. You can see that we have connected, and I can send messages to it. I'm just going to cheat and copy some code over from here. This one is telling the page to execute a piece of JavaScript. I'm querying for the document title, and I'm going to get that in the WebSocket response. It's actually here. Alright, so it might not have been the right tab that I have selected. Alright, that's if you want to check out more, they have documentation for this, or I'm going to show you something else. Let's go meta here. You can actually inspect the inspector itself. So I'm inspecting the developer tools that I have connected, and if I just filter for WebSocket messages and refresh this page, then these have already been sent by the browser for loading the page, and I can just look at anything I want and get the WebSocket message for it. All right. Alright, 2016 saw the third release of Selenium WebDriver. And around that time, the Selenium guys managed to agree with browser vendors that they are going to be responsible. They take over the responsibility for maintaining the drivers for their own browsers. And they also created a WebDriver protocol specification on W3C. Last year, so the appearance of headless mode in real browsers, Chrome and Firefox. You can now start up your Chrome in headless mode. On Windows, you also need to disable GPU. And you can use the same binary that you're using to open up Chrome as a CLI tool for taking screenshots or entering REPL mode. This also allows us, in connection with remote debugging, to remove the debug different machine. So if I open up my IP for connection, then you can debug my Chrome remotely. Yeah, sounds interesting, and it comes with responsibility. Yeah. Second part of 2017 saw the appearance of the release of Puppeteer, another tool by Google for automating the browser, and the 8th version of Node.js that came with async functions. This is going to be interesting for us when writing end-to-end tests. Let's talk about Puppeteer. It's similar to the Chrome remote interface that we have seen before. The difference here is that instead of a low-level API, it provides a high-level API. So more abstraction here, no detailed work with the WebSocket protocol. Actually, they probably stole their name from a Firefox tool that was able to control Firefox over the Migrating protocol, and it was a Python project. So when you install Puppeteer, it comes with a Chromium binary that it installs under your node modules. Taking a screenshot with Puppeteer looks like this. You open up a browser, open a new page within the browser, navigate that page, and then just take a full screenshot and then save that out as litigo.png, and then you close the browser. So the same things that I have mentioned for Phantom.js and headless browsers also apply to Puppeteer. Whenever you find yourself wanting to parse HTML, then you should probably consider using a headless browser. I give you some moments to consume this. So instead of parsing HTML with regex, which you definitely shouldn't do, you could just start up a headless browser, and there you have DOM access. You can evaluate any piece of JavaScript within the browser. This one just removes any unnecessary attributes from a web page. Then you can also do server-side rendering with Puppeteer. Most of all single-page applications construct the DOM, and in the source code, your source HTML file, you have nothing but a single tag. And that's not useful for SEO purposes. But with Puppeteer, you can very simply, in only 6 lines, server-side render your application in whichever framework you have written it. Okay, so So let's jump to the next phase. We faced having to create an end-to-end testing solution, and the first thing on that road for us was trying Puppeteer. Now there were some problems with that, and that's why we migrated to jest and Puppeteer, and now I'm going to talk about why and how we did that. So this is just a very simple Puppeteer test example. It's navigating a browser page, and it queries an element and gets the text inside it and checks if its text content is chained over. Now actually this code shouldn't work. Do you have any guesses why?
By is not defined.
Sorry?
By is not defined.
By is not defined. Okay, it's defined in Protractor.
Because it looks like synchronous code.
Yeah, it looks like synchronous code, but is actually asynchronous. All these commands are asynchronous, and if you were to just execute it like this, it wouldn't work. However, it still works, and that's the magic of WebDriver.js. And it's called Promise Manager. It's a 3,000-line beast, and they have always found it hard to manage this. And finally, with the release of Node.js 8 and its support for async functions, they decided to deprecate this beast. So if you're starting a new Protractor project, you should consider using an alternative, and that's what I'm going to talk about now. You can very simply disable the Selenium control flow and migrate to async functions with a few async keywords. They stop the execution until the awaited promise resolves, and only then go to the next line. Okay, so from code like this, which is rather common, this one is only getting the option text in drop-down elements. You can transfer to something like this, much more readable, I think. However, there are some parts in Protractor that can't be asyncified. There are some APIs, and as a result, I still have to write code like that in the middle, and that's because it relies on its own promise and its special denable objects that cannot be awaited. So to sum it up, for us, it was just Protractor had just too many layers. You have the browser driver, the Selenium server that acts as a proxy, WebDriver manager that starts up Selenium server, then WebDriver.js, then they even extended it, and then Protractor itself. Way too many layers, and they make your tests fragile. Also, what I haven't mentioned is mocking was difficult, and with Protractor or WebDriver, you don't have control over new features in the browser. But luckily, Puppeteer is an answer for that, and the way we created an end-to-end solution with it was integrating it with Jest. Now, Jest is a test runner by Facebook, and it served us really well because it can run tests parallel in separate node processes and handles promises by default. So does with async functions, because they just return promises, and it provides us custom test environments where you can tweak some integration code with Puppeteer. Here's the step of the processes that get run and where you can tweak into Jest. Through a test run, it all starts with an npm script that calls a JavaScript file. That JavaScript file is going to run the Jest CLI. The next step is Jest's global setup. It's a relatively new feature. This code runs before starting the testing process. Then the next one, and it's already in a black box because it's running in a separate process, so you can't communicate from a global setup to anything in here with with Node's global object. Next one is the environment setup. This runs before running every test file. Then the next one, where you mostly tweak, is your before all. It runs before anything in the describe block, and before each, which runs before every it function in the describe block. And here's how you can do the integration. In the global setup, we launch the browser, and we're going to just close it in the end. After testing, in the environment setup, I open a new page for each of my tests and do all sorts of optimizations I'm going to talk about later. In my before all block, I instantiate my page objects, and in before each, I navigate or refresh the page where I want it to go. Here are some of the optimizations that you can do and are rather easy doing with Puppeteer. You can emulate any mobile device, abort requests that you don't need, that load resources that are not necessary for an end-to-end test, and then transfer any console logs from the browser or errors to the terminal. Here's what mocking looks like. In Puppeteer, I'm just listening to the request event, and if the request is for an image, I'm just going to abort it. And if the request is for an API endpoint that takes a long time to load, then I'm just going to respond with my mock instead. And similarly, I can subscribe to console events and transfer them to the terminal, or any page crashes, and log them. Now with the DevTools protocol, you also have the ability to test new features, new browser features from the progressive web apps spec, like simulating an offline mode, and that's useful for testing your service worker, and also you can test if cache is working properly, if service worker is properly working. All right, and at this point, let me just give you a quick demo of what it works, how it works. I have several options, several ways to start my tests. This one is going with a graphical user interface, and it opens up Chromium by default. I have added a special flag to open up DevTools, also so that I can see. And this is just automating our homepage. But what is more interesting for us is how we can debug this thing. I can start this thing up in debug mode, which means I can inspect my test from the browser. Here I've got this Node.js icon, which I can click, and my tests don't start until I resume the script execution. Anytime, and you should also see this thing. And at any point, I can just pause script execution and really just debug, go line by line in my test. All right, still one of the drawbacks you might consider if you have used Protractor so far. How many of you guys have used Protractor or are using Protractor? Mm-hmm. Is that it doesn't wait for your framework. You still need to wait for selectors to appear. But that's just one more line everywhere, probably. Okay, so summing it up, it might not be a solution for you if you have the need to run against Microsoft browsers or any other browsers, because it only runs in Chrome, and but it comes with many advantages, like having control over the complete DevTools protocol and testing many new APIs in your browser. So it's also a convenient solution for running your tests in your continuous integration environment, for which you just simply set up a Docker which installs a Chrome instance, and then you have multiple ways to connect to Chrome instead of Chromium, with an executable path or with a browser WebSocket endpoint. You can get that at localhost 9222. But also a warning, the newest releases mostly work with unstable versions of Chromium. So if you want to try this out, you probably want to stick with older versions of Puppeteer so that you're running against stable Chrome. And the last word of warning from me is that you should watch out for open browser instances. Don't leave your computer unlocked, because anyone can control your browser from even a remote machine. And always double check the dependencies of the dependencies you install from npm. With a simple post install script, you can do anything with Puppeteer. Open up your existing browser and steal cookies or JWT tokens from local, or also allow access to newer install any new service workers, and give them access to things like image recording API or things like that, so people can see you remotely. that's my word of warning at the end. And if you have any questions, you can ask them now. Questions?
How do you test for other browsers?
We don't test for other browsers. Yeah, that's a drawback. Yeah, but in most cases you don't want to run your tests in multiple browsers at the same time. That just takes too much time, and in the continuous integration you wouldn't do that.
I have another one. Is this a good tool for stress testing? Actually, your backend? Can you use it for that as well?
Stress testing backends?
Yeah, like launching, I don't know, thousands of instances of browsers on your servers and kind of DDoSing your APIs. Is this something what you have been looking into?
No. But yeah, there.
The problem with that headless clone is using a lot of memory and resources, so it stress tests your test less.
Yeah. Okay. Thank you.
I just wanted to ask, so Norby cannot. So, have you considered Cypress IO maybe also?
We have looked at several options. Cypress, I don't recall if we looked into that, but we can take that after the presentation.
I wanted to do the same thing, but they beat me to it. Good job, Dave.
Yeah, or anything, if you have anything to add to the history, any other tool I missed, then I'm happy to talk to you. Okay then, yeah, one more
I'm not
question.
sure if that fits in the dream, but can you tell us a word about code coverage?
Code coverage.
Yes.
Testing, you can, I don't know if Jest has test coverage in itself. I wonder if one of you guys know that, but you can certainly integrate that with a test coverage tool.
So it's out of scope.
Yeah, because in this case, for end-to-end testing, you don't really have a meaning for test coverage. You're not testing every single function of your code with end-to-end tests. It's only the 10% complete user flows and not pieces of code.
Do you have any known solution to use this framework with Gherkin syntax?
With, sorry?
With Gherkin syntax.
Gherkin syntax. Yeah. We have also looked into that, and it can be integrated. And it's a possible option because Jest can be integrated with Gherkin, and we have also considered that and might integrate it in the future.